Okay, what we're going to be doing today, the time that we have left, is kind of tying things together, alright? And hopefully what we'll be able to do is to tie together things that we've seen in the unit circle, things that we've done kind of practically, with a graphical representation, alright, of sine and cosine. That's our goal today, is to be able to recognize the sine and cosine graph and see where they come from and some of the features of these graphs. Before we get to those specifically, though, I want to talk just briefly about periodic functions in general. First of all, just answer the question, what is a periodic function? Well, a periodic function is something that has a period and an amplitude. Okay, a period is a portion of the graph that repeats exactly over and over and over again. Okay, I'll show you a picture of one. I liked this one. It kind of looks like the Batman periodic function or something. I don't know what in the world the graph of that would be, but it looks pretty cool. But you'll see here that if we were to break this, starting on the y-axis, starting where x is 0, you can see this pattern repeated. Looks like a whole bunch of Batman standing shoulder to shoulder or something, okay? But you see this pattern repeating over and over and over again. Each of those can be referred to as one period of the graph.
So every time it repeats?
Every time it repeats is a period of the graph. Okay? So you'll notice as I go from here, it goes down and then up to the point, and then loops down, goes down all the way down to here, and then back to there, and we've gotten back to where we started. And it continues. Okay? That's known as one period. When we're talking about the period of a graph, we're talking about a numerical value, a range of x values that it takes before the pattern will repeat itself. Okay? So in this case, you'll notice it goes from 0 over here to 4. So 4 units, whatever this unit of measure is, 4 units would be the period, and we usually use a capital P to represent period. Now the amplitude, on the other hand, the amplitude is talking about how high and low our function goes, okay? You'll see here we have a formula. It's half the difference between the min and the max value. Okay? So here we have all of these that are the highest points that our graph goes. And let's say that that's y equals 4 for the max. Okay? You okay?
Yeah.
Do you lose the contact or do you get back in?
I'm right.
Okay. So that's our max. And then down here would be our min. Okay? Let's say that that's y equals -2 for our min. And I know that's not drawn to scale or whatever, but we're just putting numbers on it. If I were trying to find the amplitude of this periodic function then, what I would do is I would take the difference, half the difference. So the difference is 4 minus 2, or I'm sorry, 4 minus a -2.
That's 4 plus 2.
So it's 4 plus 2, and then I would cut that in half. It's half of that distance. So yeah, it would be 6 divided by 2. Our amplitude in this case would be 3. Okay? Now this is one that people often forget to divide by 2. Because you think amplitude, oh, how tall is it? That's not exactly what we're talking about. we're actually talking about the fact that, we could have this kind of central line going horizontally through it. And again, I know this isn't drawn to scale. Okay, it doesn't like my pen for some reason. Let's try that again. Okay, so we've got this central line, there we are. And to get up to the max point, we would have to go 3 units up. To get down to the min point, we would have to go 3 units down. Okay, because our amplitude is 3. Alright, so that's what amplitude is. It's kind of the distance from the middle of our periodic function. Okay. Now, periodic functions are used in a lot of different applications in real life scenarios. Okay. Anything to do with waves, light waves, sound waves, any of those things can be modeled using a sine or cosine curve that we're going to see today. In fact, if you want your sound to be louder, you need to increase the amplitude. That's what an amplifier does. Okay? It increases the amplitude. If you want to change pitch, you need to change the period. Okay? Those of you in music might be familiar with the A440. Okay, that's like the tuning note. When you hear the orchestra start to tune and you hear that one, well, it's usually the oboe, but then the violin will play that one note and everyone starts tuning off of that. That's A440. That's because there are 440 cycles per second. That period gives you the note that we know as A. And the cool thing is if you doubled that to, from 440 to 880, you'd have the same note, but it would just be 1 octave higher. And if you cut it in half, it'd be the same note, but 1 octave lower, and so forth. I had an old calculator, an HP graphing calculator, that actually it had a program for tone, and you could type in the 440 and a number of seconds to hold it for, and you could program songs if you wanted. There was one guy in the class who did that in college.
So basically it's like octaves or like periods.
Octaves are kind of like how many periods would you fit in there. 440 would be normal. If you want it to be twice as high, so to speak, or if you want it to be 1 octave higher, you have to cram 2 of those in the same space. So you double the period. Or if you want it to be an octave lower, you stretch it out so only half of it is in that same amount of space. Okay. Now, one fact about amplitude and period you need to remember is that they are always positive. There will be graphs that we'll look at, equations that we'll look at, and you'll be tempted to say that your amplitude is negative, but it's not. Amplitude is always positive. What you can have, though, is a reflection across the x-axis. Alright, and we'll see that. And all those things that we were doing in the first few chapters with transforming graphs, we're going to apply to our sine and cosine curve actually tomorrow. Alright? Now, let's look at sine, and I already graphed it for you, and then we'll actually graph cosine. Here's sine, and I used my unit circle, and I just went up by pi over 4s. I didn't do the pi over 6, pi over 3, and so on. I just used the pi over 4s. And I used the unit circle. When my angle is 0, the value of sine is 0. And you'll notice I'm graphing the points now, not as points on the unit circle, but I changed my x-axis to represent the angle that I'm taking the sine of. And the y-axis is going to give me the value of sine at that angle. Okay? So when the angle is 0, sine equals 0. So I hit the origin. When the angle is pi over 4, what does sine equal? According to your unit circle.
Root 2 over 2.
Root 2 over 2, which is about 0.707. Okay? When our angle's pi over 2, sine equals 1. When the angle's 3 pi over 4, sine is root 2 over 2 again. At pi, sine is 0. At 5 pi over 4, sine is negative root 2 over 2. At 3 pi over 2, sine is negative 1. At 7 pi over 4, negative root 2 over 2, and then we're back to 0. Okay? And there's a lot of different things we can observe now from this graph, but that's one period of the sine curve. If we went on to 9 pi over 4, we'd get the same thing that we did at pi over 4 because those are coterminal angles.
Have your attention, please, all residential prefix. A reminder, there will be a meeting in room 111 right after school.
So, you can also see if you looked at multiple periods, if you go to the same position through the period, you have coterminal angles. Alright, so like I said, 9 pi over 4 is a coterminal angle to pi over 4. They would both have the same value. Okay. Now let's answer some of these questions down here. What's the domain of sine?
All real numbers.
All real numbers, okay? X is any real number. Alright, you could write it like that. You could write the words out, or you could say negative infinity to positive infinity if you wanted, using the interval notation. Okay? What would the range?
1 between 1 and negative 1.
Yeah, between negative 1 and positive 1. Can it equal negative 1 and positive 1?
Yeah.
Yes. So how do I show that? With an interval, sorry. Okay, make it a closed interval with the brackets rather than the parentheses. Okay? Good. And yeah, you could put y is between negative 1 and 1 and make sure it's less than or equal to signs as well. What's our amplitude? 1. The max is 1. The min is negative 1. 1 minus the negative 1 is 2. Divided by 2 is 1. In this case, that midline, that center line that I was telling you about, would be the x-axis. And we go up 1 to get to the max, we go down 1 to get to the min. And then finally, how long does it take before we start repeating ourselves?
Pi.
2 pi. Okay, 2 pi. This is one period. It goes from 0 to 2 pi. The next one will go from 2 pi to 4 pi, and so on. So our period is 2 pi. Alright? Does that all make sense? Again, if you know your unit circle, it's easy. Alright? Let's look at this. It's the same graph. I just want to have some things labeled. We have some min points, some max points, some x-intercepts, which are also known as zeros, you guys know. But I thought this was interesting. They labeled it where we had the first quarter of the period. Here's the quarter period, okay? And then here's the half quarter period, so this is the second quarter. And then this would be the third quarter and the fourth quarter, okay? What do you notice about the first half of sine? It's always positive. What does that represent? The first quadrant and second quadrant, right? Here's our first quadrant. I'll call it Q1. Here's our second quadrant. The third quadrant and fourth quadrant, sine is negative, okay? So, there you can see on the graph where sine is positive and where sine is negative. Okay? I just thought that was the way they labeled that really would help us remember. You know, if you don't remember that all students take calculus, sine you can get just by looking at the graph. Okay? All right. Go ahead in your notes there and make a copy of this, except don't put the sine in there. We're going to do cosine. All right? But we're going to use these same angle measurements. So start with your y-axis, draw a nice long x-axis, and do the pi over 4, pi over 2, and so on. Okay? Then use your unit circle, and you can work together with somebody if you'd like. Use your unit circle to find these values. You know, we had 9 points. Okay, so try to find those 9 points using your unit circle and cosine. I'll give you a couple minutes. You might need paper. Okay? Feel free to work with somebody.
So, what? So we're doing the cosine one, right?
Do the cosine one. So just like we talked through, what's the sine of 0, what's the sine of pi over 4, what's the sine of pi over 2, do the same thing but do the cosines.
It's still gonna be pi over 4, pi over 2.
Yeah, do the same angles. Okay? And remember, root 2 over 2 is approximately 0.7 over 707. Okay? See how many of your graphs look right.
So, 7,
Period is 2 pi, right?
Period's 2 pi. Yep. Use your unit circle. Guys. You have your unit circle that I gave you? Well, figure out what I asked you to figure out. Okay?
so it's the same. Does this one still go through the origin? Or
Well, look at your unit circle. What's cosine equal when your angle's 0?
so oh, and then pi over 2 is 1, 21. Pi over 2 is 1, 0, 2.1. This is 1. I know that.
We're only doing the pi over 4s.
Yeah. Yeah. Pi over 2 is going to be 0. I know it looks like. Oh. You want to give like 0. Well.
Oh, you know what? That pi, your x, oh, you know what? You labeled that one wrong. That's negative 1, 0. That's why. And I think that threw off a couple of things as well there. Someone want to put theirs up if they're done? Well, no, this one, when x is 3 pi over 4, the point that I was pointing out here is this point right here. Okay? So that's the angle 3 pi over 4. The y coordinate is sine of 3 pi over 4, which is root 2 over 2. Okay, so that's 3 pi over 4, root 2 over 2. Right here. pi over 4 is it equal to the same thing, yeah.
那你这玩意儿你看
Does anyone want to put theirs up here?
Yana does.
I'll do it.
Alright,
I don't know if it's right. It's all Jillian's fault if it's wrong.
That means if it's right, it was my idea.
so if it's alright, it's all hers too.
Julian's not right. You're saying.
Don't hang up on me.
Don't lie. Wait. Don't lie. Don't even do it right It's like,
So cosine at angle
Here.
0 is 1. At pi over 4, it's root 2 over 2, right? Or at pi over 2, it's 0. At 3 pi over 4, we're at negative root 2 over 2. At pi, we're at negative 1. 5 pi over 4, we're at negative root 2 over 2. At 3 pi over 2, we're back to 0. 7 pi over 4, we're at root 2 over 2. And at 2 pi, we're back up to 1. All right. Good. Good.
Teamwork.
Okay. Now, notice here, I know I put little arrows on the ends. It's not saying that that just goes up forever. It means the period continues. I just want to make sure you guys understand that. All right, so, you know, if we were to keep drawing this, you know, it would just go back through another period this way. This one, it would go through another period that way. Okay. But that's good. You see an entire period of the cosine curve. Alright? Does everyone understand that? Okay. And if we took that then, we'll see how well this works. If we took that then and laid it on top of this one, okay, you'll see the shapes are the same, okay? And this one's a little bit taller because our scale isn't exactly the same. But you see the idea. It's just shifted over. How far over is it shifted? 90 degrees or pi over 2. That sure sounds like what identity that we learned?
cosine theta equals to sine 90 degrees minus
Cosine of theta equals sine of 90 minus theta, right?
The co-function identity.
The cofunction identities, yeah. There's a shift here, okay? So, there you have it, okay? Any questions about that graph?
is this like the same thing where it divides into 4s?
Yes. You see here, okay, there's your first quadrant, second quadrant, third quadrant, fourth quadrant. Where is cosine positive?
first and
First and
fourth.
fourth quadrants. Well, that's right here and right here, right? There's our first and fourth quadrant. Here's the second and third quadrant where it's negative, okay? You can see that there.
Mr. Dixon, why it's
Yes.
going to 1?
Why does it go to 1?
Yeah.
On the unit circle, the highest we ever get is at 0, 1. Okay? Do you remember your unit circle? That's the point you have there. Okay? So that's the highest we can get. Is 1, and the lowest we can get is -1. Alright? Let's run through these real quick here to make sure we've got them all. What's the domain of cosine? Good. X is all real numbers. What's our range?
1.
Good. -1 to 1. Whoops. Bracket. What's our amplitude? 1. And what's the period? 2 pi. Good. So you see, sine and cosine are very, very similar. In fact, that's all identical. Okay? Sine and cosine are so similar, it's just one is shifted over 90 degrees, so pi over 2. Alright? Any questions? Alright, tomorrow we're going to look at how